Hello all, good day, welcome back to Offline Techie. Today we will discuss about build systems in Qt. Also should know what is CMAKE and QMAKE. Okay, let's start. A build system in Qt is the set of tools and configuration files that automate the entire process of converting your application's source code into a final executable program. In Qt development, this involves much more than just compiling C++ files. It includes managing dependencies on Qt modules, such as core, GUI, and widgets, handling platform-specific settings, and running Qt-specific pre-processing tools that support key features of the framework. For example, Qt relies on components like the meta-object compiler, CMAKE, to enable signals and slots, the user interface compiler, UIC, to transform .UI design files into usable code, and the resource compiler, RCC, to bundle assets like images and translations into the application. A build system ensures all these steps happen in the correct order and with the right configuration, so developers don't have to manually manage complex compilation commands. Traditionally, Qt used CMAKE, which uses simple project files to describe how an application should be built, but modern Qt development primarily uses CMAKE, a more powerful and flexible system that is widely adopted across the C++ ecosystem and supports large, cross-platform projects. Overall, the build system acts as the backbone of a Qt project, coordinating code compilation, library linking, resource management, and platform compatibility to produce a working application efficiently and reliably. What is CMAKE? CMAKE is a powerful, cross-platform build system generator used in C++ projects, including modern Qt development, to manage the process of compiling, linking, and organizing software builds in a flexible and scalable way. Instead of directly compiling your code, CMAKE acts as an abstraction layer. You write configuration instructions in a file called cmakelists.txt, and CMAKE translates those instructions into native build files for your system, such as make files on Linux or Visual Studio project files on Windows. This means you can write one set of build rules and use them across different operating systems without rewriting them. CMAKE is especially valuable because it not only compiles source files but also handles complex tasks like finding and linking external libraries, managing dependencies between different parts of a project, setting compiler options, organizing large code bases into modules, and supporting out-of-source builds, keeping build files separate from source code. In Qt projects, CMAKE also integrates seamlessly with Qt-specific tools like the meta-object compiler, CMAKE, user interface compiler, UIC, and resource compiler, RCC, automatically invoking them when needed so features like signals and slots, UI forms, and embedded resources work correctly. One of CMAKE's strengths is its declarative style. You describe what you want, example create an executable and link it with Qt core, and CMAKE figures out how to do it on the current platform. It also supports advanced features such as build configuration types, debug/release, conditional logic, cross-compilation for embedded systems, and integration with testing frameworks and packaging tools. Because of its flexibility, scalability, and strong ecosystem support, CMAKE has become the standard build system for modern C++ and Qt6 development, replacing older tools like CMAKE in most professional projects.
What is QMAKE? QMAKE is the traditional build system created specifically for the Qt to simplify the process of building Qt applications by automating compilation, linking, and project configuration. It works by using a simple project file format, .pro files, where developers describe their application such as which source files to compile, which Qt modules to use, like core, GUI, or widgets, and any additional settings like include paths or libraries. Based on this .pro file, QMAKE generates platform-specific build files, such as make files on Linux or project files for IDEs like Visual Studio, allowing the same Qt project to be built across different operating systems without rewriting build instructions. One of QMAKE's key strengths is how tightly it integrates with Qt's internal tools. It automatically invokes the meta-object compiler, CMAKE, for handling signals and slots, the User Interface Compiler, UIC, for converting .UI files into C++ code, and the Resource Compiler, RCC, for embedding resources like images into the application. This makes CMAKE especially beginner-friendly because much of the complexity of Qt's build process is hidden behind simple configuration lines. Additionally, CMAKE supports basic logic, conditional statements, and variables, enabling developers to customize builds for different platforms or configurations, such as debug and release. However, while CMAKE is easy to learn and works well for small to medium-sized projects, it is less flexible and powerful compared to modern systems like CMAKE, particularly when dealing with large-scale projects or integrating third-party libraries. As a result, although CMAKE is still supported and widely seen in older Qt projects and tutorials, it is gradually being replaced by CMAKE in modern Qt development due to CMAKE's greater scalability and ecosystem support.
Which is best? When comparing build systems in Qt, CMAKE is generally considered the best choice for modern development, while CMAKE is more suitable for simpler or older projects. CMAKE stands out because it is a powerful, cross-platform, and industry-standard tool that is not limited to Qt, allowing developers to manage large and complex projects with multiple modules, external libraries, and advanced configurations. It provides greater flexibility, better dependency management, and seamless integration with modern development tools and environments, making it ideal for professional and long-term projects. In contrast, CMAKE was designed specifically for Qt and offers a simpler and more beginner-friendly approach, using easy-to-write.pro files that automatically handle many Qt-specific tasks like signals, slots, UI forms, and resources. However, this simplicity comes at the cost of limited scalability and flexibility, especially when projects grow in size or require integration with non-Qt components. As Qt has evolved, particularly with Qt 6, CMAKE has become the officially recommended build system due to its robustness, maintainability, and widespread adoption in the C++ ecosystem, while CMAKE is gradually being phased out for new development. Therefore, although CMAKE is still useful for learning and maintaining legacy code, CMAKE is the preferred and future-proof option for building modern Qt applications. Thanks for watching. You will get more idea about this while explain project-based development. Stay tuned for upcoming videos.